In this question, we're asked to draw the graph of y equals f dashed x given a function y equals f of x and its turning points. When we differentiate a function, we get the derivative, which is also known as the gradient function. By subbing in values of x, it will return the value of the gradient on the original function at that point. So what we need to do first is consider what the gradient is at different points on the curve y equals f of x. So we can see that up to the point where x equals 1, the gradient is going downhill, i.e. negative. At the point where x equals 1, we have a minimum turning point where the gradient is 0. To the right of the point x equals 1, the curve increases, so positive gradient, up to the point where x equals 3, which is a maximum turning point, therefore also gradient equals 0. To the right of the point x equals 3, the curve is decreasing and we have a negative gradient again. What we have to do is sketch these gradient values on a graph y equals f dashed x. Now to do this, we'll start off by drawing a set of axes. I suggest to do it directly below the original sketch. So the x-axis is plotting x values, but the y-axis this time is not plotting y coordinates, but values of the gradient on the original function. Now we have two turning points where we ignore the gradient precisely. Where x equals 1, the gradient equals 0. So when x equals 1, we're sitting on the x-axis, so gradient equals 0. Also, when x equals 3, the gradient is 0 as well on the original curve. So x equals 3, gradient of 0 on the derived graph. Then back to the top graph, to the left of x equals 1 we have negative gradient. We need to pass through 0, positive gradient, 0 gradient, and then negative gradient. So above the x-axis will be positive gradient, and below the x-axis on the derived graph will be negative gradient. So we're starting negative, we have a gradient of 0, going positive, but we need to return to 0 gradient and go negative again. So this is y equals f dashed x.